So in previous video we discussed about the transaction process. Transaction process means what? Execution of the two process. What are those? Read and write. Next we'll continue with the same thing, read and write operations. So here we using the one of the command, that is the write item X. Write item X is a command. It includes the following steps. What are those? Let's see. Find the address of the disk block that contains item X here. If I execute this write item X, so what this command will do? It checks for the address of the disk block which contains this item X and copy that disk block into a buffer in main memory. If it is not already in some main memory buffer, if in the main memory buffer if it is there, it's okay. Otherwise, what is the thing? So from the address disk block, it is copy into the main memory buffer here, temporary buffer it is, okay, and copy item X from the program variable named X into its correct location in the buffer. So now what are the new value are written for this item X? That one it is updated in the buffer memory variable. So store the updated block from the buffer back to disk here. And one thing you remember, as I told, okay, backend and front end. So you have to need to transfer the data from backend to front end, and in the front end you can modify that data here while making the transaction, okay, or while transferring the data. So usually you are not allow the data, okay, application program how the access the front end data, sorry, back end data here. Front end is not having the authority to directly access the data with whatever it is there in the back end here. So if you want to access, what is the thing you have to do? First you have to access that from the disk and you have to store in a buffer as a main memory you are called. So in the main memory you are using the buffer. In the buffer first it has to store it and later it allow that program to access that and it allow that data to modify here, okay, because thing is what it is this, okay, in the back end what are the data you are stored, no, you have to manage that data here, okay. So due to that reason, so here you are taking the help of the buffer. So programmer can have the authority to make modification in the data whatever it is available in the buffer. Once the transaction is completed, once after that it copy that back to the disk here, okay. So this is about your write command here. So in the transaction, you are using some of the notations. What are those notations? Let's see. So in the transaction, read and write operations are available, and here we are going to use the shorthand for this read and write operations. T1 indicates transaction 1 and T2 indicates transaction 2, and as I told, all the transactions having the boundaries, that is the begin and end. So B indicates the transaction beginning and E indicates the end of the transaction here, and this transactions IDs are unique here, okay. So T1, once if it is I taken for this transaction, then for next transaction T1 is not repeated, the transaction, okay, ID is also unique here. So here R indicates read operation and W indicates write operation. B indicates begin and E indicates end here. R1X, meaning of this one is what? Read item X. W1X means what it is? Write item X. 1 indicates the transaction 1 here. 2 indicates the second transaction. These are the some of the notations which are you are going to use in your transaction process here. These are the two simple transaction example for the transactions here. So one is T1 and another one is the T2. Read item X. Okay, as I told, read item X means what it is? It reads the item X here. What are the, okay, data it is there in this item, that data you want to read now. So for that, what is the procedure you have to do now? You have to read from the, okay, disk, and later you have to copy that to the, that value it is available in the main buffer, and program can access that from the main buffer here. So read item X, okay, X equal to X minus N here. So this is your first transaction. You are accessing the item X and you are modifying the, okay, that item by subtracting with the n here. N is the another item. After subtraction, what are the result will get? That result once again you are storing in the x. It is very simple. Here you are updating the value or modifying the x value here. Write item x. Write item x means what it is? This x value now it goes and stores in the buffer here. Okay, so from the buffer later it is copied to your disk here. So this is the transaction. Read item y. Read item y means what it is? Now you are getting the item from the backend to your buffer, and from the buffer main program will access this variable y here. Okay, after accessing that it modifies. Your program will modify by using one of the one of the mathematical operator plus n here. It adds the value for this y here. Like this you are modifying the y value in your application program. After modification this value must be reflected in your disk. So for reflecting that you are using the write item y. Write item y means what it is? So now it copy this value y value from program variable to your data. Okay, y item which is available in the buffer, later it is copied to your backend here. This is one transaction. In this transaction what you are doing now? You are accessing the x and you are modifying the x value with the help of the n. In the same way you are accessing the y variable, y attribute, and you are modifying that attribute value using the program as a variable y here. And after modification you are writing or updating that one in your database here. So this is your second transaction. Here also you require to access this item x using read item x. It accesses the x as an attribute. So now it copy that attribute to the program variable with the help of the buffer here. Later in the program variable you are modifying the values. In your application program you are modifying the x value. After modification you are copying that variable to an attribute. That attribute is your data in the database here. For that you are using the write item x. So these are the two transactions. Here you are using the two process read and write. So here read and write you are using to modify the x and y value. In transaction 2 you are using the read and write operation, and you are here what you are doing here, just you are modifying the x value here. So this is about your transaction processing. Next I told concurrency control is also very important in your if you are using the multiple users, multi-users transactions if you want, then you have to go for concurrency control. In concurrency control you are in the two ways. Either you use the single CPU. In the single CPU concurrency control is called as interlude. You are giving both the transactions to access by using the interlude concept. If you are using the multiple CPUs, then you are going for parallel concurrency control. In parallel concurrency control, both the transactions you are executing parallelly. Whereas in the interlude, in sequence, but in the sequence also both the transaction it goes in interlude here. So why we go for concurrency control? In the transaction process. Without concurrency control, problems may occur in concurrent transaction. So if you are going for concurrent transaction, it creates the problem. That's why you have to control the concurrency. So what are those problems? First one is the last update problem. So last update problems occurs. When it occurs? When two transactions update the same data item. But both read the same original value before updation. So now in the previous example only, I taken the example, no, same thing it is here also. So in this example, T1 and T2 both will access the item X here, and both want to make modification the X value. T1 also send the request for accessing the item X. At the same time, T2 also send the request for accessing the X here. So now T1 will make the modification in the X value by subtracting by N here. So T2 is making the addition here. So later once, okay, after completing these two transactions, what is X value? Okay, so assume that here I'll take the example. X value it is at present in the database, X value it is 10 here. Okay, and N value it is 2, and sorry, M value it is 3. Okay, N value is 2 and M value is 3 here. T1 want to subtract the, okay, X value by 2, and T2 transaction want to update the X value by adding 3 here. So both will send a request to access the X value. At present X value is what now? 10 it is. So now here also it is 10, and for this also it view as a 10 here. So if I execute T1 first, then what happens here? X value it is becomes 10 minus 2. 10 minus 2 it is what it is? 8 here. In the same way here if I execute, then 10 value it shows what it is? 13. So now here it is in the dilemma, which one is the correct value, because for the same X value you are getting the two values here, whether it is 8 or whether it is 13 here. Okay, so that is the problem what we call last update problem. So last update problem means what it is? Both read the same original value before the update here. Okay, one of the updation it is not reflect to another one here. Then what happens here? So then you will, okay, here if I execute this two transaction, actual thing is what it is, if I execute this transaction first and if I modify, the next value I'll get as a 13, and for that one if I subtract 2, okay, then I'll get the value as 11 here. Okay, concurrency control. In the same way, first if I do this one 8, next if I execute this one 8 plus 3, then you also will get the 11 here. So if your modified value it is reflected, okay, one second. So if I modified that value, if it is reflected, then I'll get the same value in both the, okay, in the X, in both the transaction, I'll get the X value as 11 only. But, okay, so if I'm not control, okay, concurrency control, if it is not there, then what happens here? I'll get the two different values. For the X here I'll get 8, and here I'll get the 13 here. This updated value is not reflected in T2, and this updated value is not reflected in T1. So that is what we call as a, okay, last update problem here. Next is the temporary update or dirty read problem here. This occurs when one transaction T1 updates a database item X, which is accessed by another transaction T2. When T1 fails for some reason, then X was read by T2 before its value is changed back here. That is what we call as a rollback or undone after T1 fails here. So for example, I'll take your this one only, bank transaction only. So two users are there, user A and user B here. Now user A want to transfer the amount 500 amounts from user A to user B here. So in user A account you are having the 1000 as a balance, and in user B account you are having the balance as a 2000 here. So now user A want to transfer the amount here. For transferring that, what is the thing here? So in the 1000 I have to minus this 500. So then what is the account balances available in A user? For the A user balance is 500. So now when it is transferred to the this one, so 500 it is there in the account A user here. Before it is reached to the account B, okay, B user account. So what happens if the transaction fails here? Okay, so before it is updated in the transaction B, before it is reached to the transaction B, okay, account B, if failure occurs, what happens here? In the user A account you are getting as a 500 as a balance, and before it is reached, transaction fails due to some problem. In user B account also you are having the account as a 1000 here. Then where that 500 amount goes, that is what we call as that problem what we call as a temporary update or dirty read problem here. That's why, so if transaction is not completed before the transaction, if any failure occurs, then you consider that one as what? Transaction is not taken place here. So not taken place means what it is? So before subtracting, what are the transaction in account user A account 1000 if it is there, no? So if it is not completed, so incomplete, before completion if any error occurs, then in the DBMS system, it consider that one as the transaction is not taken place here. Not taken place means what it is? You will get the before transaction, what are the data it is there? That data you will get back as it is. That is what we call as a rollback or undone here, okay, to prevent from such type of the problems here. So, but, okay, here before that problem, okay, if it is rollback or undone, T2 transaction if it is completed, that is what we call as a dirty read problem. So, this is the example here. Transaction T1 fails and must change the value of x back to its old value. Meanwhile, T has read the temporary incorrect value of x here. Same thing, I'll take the x value as a 10. So now here, if I take x value as a 10 here, so n value is 2, x minus 2 means what? X value I'll get as a 8. Right item if I take, it is updated in your database also. So when this transaction 2 executes, what x value it reads now? X value is 8 now. And what it makes now? 8 plus, okay, 3 it is what becomes? It is becomes 8 plus 3 it is the, okay, that is 11 here, okay, 8 plus 3, that is the 11 here. So 11 is the value and it is also updated. 11 value is updated. But, okay, so before this transaction is completed, some problem is occurred. So in that if problem is arise, this transaction is not completed, but in temporary, in buffer it is stored. One second, why it is creating? So it is stored in the buffer, it is not reflected in your disk, okay. Right item x means what it is? Temporarily it is stored in a buffer and that buffer value it is read by the second transaction as a 8 and it performed the modification, and after modification it modified the x value as 11 here, okay. X value as 11 and here it is 8 and here it is also 8 here. So 11 if it is here, so now what happens here? If this transaction interrupted due to some problem, then what does the thing here do? It does not, it doesn't update this 8 value in your disk, okay. In your disk it is rolled back as a 10 only. So x value if it is 10 and if it is modified as 11, but actual value must be become as a 13 here. But it is value is it is stored as a 11 here. So that is what we call as a dirty read problem. Okay, temporary update or dirty read problem. This is the second one. Next is the incorrect summary problem. One transaction is calculating an aggregate summary function on a number of records. For example, sum total of all bank account balance, while other transactions are updating some of these records. For example, transferring a large amount between two accounts. The aggregate function may read some values before they are updated and others after they are updated. So here you want to perform the aggregate sum, okay, sum as a one of the aggregate function and you want to calculate that sum here, total sum here. So in that, okay, so while performing the, okay, aggregate sum function here, so number of records, assume that 5 records are there. So in the 5 records, 2 records value it is old one and 3 record value it refers the new one here. So now if I perform the sum of these 5 records as a aggregate function, then what happens here? For 2 you will get the new old values and for remaining 3 you will get the new values, and after that what are the updation or aggregation you will perform? No, that is wrong here. That is what we call as an incorrect summary problem. This is the example here, okay. T3 reads x after y is subtracted. Okay, transaction 3 it reads the x value before it is subtracted. and reads y before n is added. In the same way, it adds the y value before it is added. A wrong summary in the result here. So that's why you will get the wrong summary. See here, sum equal to 0, read item. I'll read the item A and I'll do the sum equal to 0 plus A here. Here I am using the read item x equal to x minus n. I am subtracting the x value, write item x here. Read item. So this one, it read the item before subtraction and it performs sum equal to sum plus x here. So sum plus x, it is what it is. Okay. So here x value, I'll take x value as what now? X value it is 10 and I'll subtract that one with the n value, it is 2. Then x value is what now? X value is 8 and 8 plus 0, some value it is read item. I will assume item A value is also 10 here. 10 plus 10, it is 18 here. So here x value is updated. So earlier x value is 10, that one you are updated. After subtracting, you got the x value is 8 here, and here while performing the sum, x value is updated as a new value x here. In the same way, if I go for the y here, assume that for the y you are having the value as a 15 and n value is 2 here. So here if I take read item y value it is 15 and sum value, what is the sum value it is there, that one it add with the 15 here. So after adding that sum total result, if I update the y value, new updated value for y is 17 here. Okay, here it is 15, updated value is 17 here, but the sum is not reflected for the 17, it is reflected for the old value here. But x value, new value, x value, new value is 8 here, old value is 10 here. Then the summary, whatever you are getting, no, it is incorrect. Either you have to consider the x and y as a old values, or you consider the both and x value as a new values here. But thing is, what happens here, x value as a new and y value as a old one, that is also not correct here. So this is about your incorrect summary problem here. Next is the unrepeatable read problem. One more problem it is comes. To prevent from that one, we have to go for concurrency control. A transaction T1 may read a item, okay. Later T1 may read the same item again and get a different value because another transaction T2 has updated the item between the two reads by T1. First it reads the T1 transaction will read the X value, then you will get the old value. After updating the transaction T2 update the X value, okay, that item value. Once again if it is read by the T1 in that particular transaction, you are reading the X value. First it is new old value and later it is new value. So that is what we call as a unrepeatable read problem. Okay, so this is why to prevent from these problems we need to go for concurrency control. If you are controlled, then you can prevent from these problems. Okay, is it clear now?